All right, let's get right into it. We're going to talk about statistics, but forget everything that made you glaze over in school. Today, we're thinking of statistics as a flamethrower, and its job? Well, its job is to burn away all the confusion, to torch bad assumptions, and to light up the simple, clear truths that are hiding in this world of overwhelming data. It's time to make it burn.
I mean, just think about it for a second. Every single day, we get hit with this storm of information. You've got stock prices, polling numbers, health reports, what's trending online. It can feel totally chaotic, right? Just a blizzard of random noise. How in the world are you supposed to make sense of any of it? Is there some kind of hidden order? Or are we all just lost in the static?
Well, that is the exact problem statistics was created to solve. It's this incredibly powerful systematic tool we use to find the signal inside all that noise. It lets us take that chaotic blizzard of data and basically burn it down to its essential, understandable core.
Okay, let's fire it up. Our first target is that fog of uncertainty that surrounds everything. We're about to see exactly how statistics lets us burn a clear path right through it.
But, to really wield this flamethrower, you've got to learn to see the world like a statistician. So we're going to walk through 3 huge foundational insights that'll give you a whole new lens. Seriously, once you get these, the way you look at data will never be the same again.
So here's the game plan for this section. First, we're going to talk about the powerful, almost magnetic pull of the average. Then, we'll dive into why extremes are totally natural and expected. And finally, we'll look at the incredible power of simply updating your beliefs. Let's jump into that first one.
Okay, this idea right here, the Central Limit Theorem, is honestly like magic. Imagine you're rolling 1,000 totally bizarre, unpredictable, lopsided dice. The outcome of any single roll is a mystery. But if you take the average of those rolls and you do it over and over and over again, the pattern of those averages will form a perfect, beautiful bell curve. It's pure order emerging directly from chaos. With enough data, the average becomes one of the most predictable things in the universe.
But, and this is a huge but, here's the other side of that coin. While the average of many dice rolls is super predictable, any single roll could be an extreme. You could roll a 1 or a 6. It's true for everything. The average height in a country is incredibly stable, but you could walk outside and meet someone who's exceptionally tall or short. Understanding that tension is absolutely key.
So how do we actually get a handle on this spread? How do we measure it? We use a tool called standard deviation. And honestly, the best way to think about it is as a single number that just tells you how wild or how tame your data is. A small standard deviation means everything's huddled together, nice and predictable. A big one means your data is all over the map. It puts a number on the chaos.
And our third big insight is all about learning. It's a formal process called Bayesian Inference, and it's basically how a statistician's brain works. You start with what you think you know. That's your prior belief. Then you get some new information, some new data. You use that new data to adjust your initial belief, and you come away with a new, smarter belief, your posterior. It's a system for changing your mind when the facts change. How cool is that?
Okay, so we've got the mindset down. Now we need the actual toolkit. It's time to gear up with the 4 essential tools that every statistician uses to burn down those false assumptions and build up some real, solid knowledge. Tool number 1 is just knowing what kind of stuff you're looking at. See, not all data is the same. Is it categorical, like sorting things into buckets, like yes or no? Or is it numerical, where you're dealing with actual numbers? And if it's a number, is it discrete, something you can count, like people in a room? Or is it continuous, something you measure, like time or height? The type of data you have dictates every single thing you can do with it next.
Tool number 2 is all about summarization. We need a way to take a massive, messy data set and boil it down to just a few important numbers. And to do that, we ask 2 simple questions. First, where's the center? We can find that using the mean, the median, or the mode. And second, how spread out is everything? For that, we can use the range, or even better, our old friend, the standard deviation.
Now, our third tool is the engine that makes this whole thing run, probability. You can think of statistics as being built entirely on the language of chance. Probability is what allows us to put a number on uncertainty, to actually measure how likely something is to happen. Without it, we're just making wild guesses. With it, we can start making some really smart, calculated moves.
And that language of probability has a grammar, a structure. We call these distributions. They're just the predictable patterns in shapes that different kinds of data tend to make. So continuous data like height often makes that classic bell curve, the normal distribution. But things with two outcomes, like flipping a coin a bunch of times, follow a completely different pattern, the binomial distribution. Knowing the shape of your data is like having a map of its behavior before you even start.
And finally, our fourth tool is how we actually make decisions. It's called hypothesis testing. Here's the basic idea. You set up a showdown between two competing ideas. On one side, you have the null hypothesis. That's the boring default assumption that nothing interesting is going on. On the other side is the alternative hypothesis. That's your exciting new idea, the effect you're trying to prove. It's a battle of ideas with data as the judge.
So, how do we declare a winner in this showdown? We use something called the p-value. The p-value is our star witness. It answers one very specific question. If the nothing is happening hypothesis were actually true, how weird are the results we just got? If your p-value is tiny, it means your data is super surprising, which makes you really start to doubt that default nothing's happening idea and gives you evidence for your new claim.
So we've got the insights and we've got the tools. Let's pull the camera back for a second and put it all together. With this new statistical lens, how does the world look different? It's time to bring everything into focus.
Because here is the single most important thing to take away from all of this. Statistics isn't just a boring branch of math class. It's a mindset. It is a disciplined way of thinking about uncertainty, a framework for weighing evidence and for making better, smarter decisions when you don't have all the answers, which, let's be honest, is pretty much all the time.
The legendary statistician Carl Pearson just nailed it. He said, statistics is the grammar of science. And that's perfect, right? Just like grammar gives you the rules to build meaningful sentences, statistics gives you the rules to build meaningful knowledge out of raw data. It is the fundamental bedrock of how we learn anything new about the world.
So I'll leave you with this challenge. Think back to that Bayesian idea of updating your beliefs with new data. What's one belief you've held for a long, long time that maybe, just maybe, it's time to hold up to the fire? What new information could you go find to really test it? Because that's the real power of thinking this way. Not just analyzing the world, but being brave enough to change our minds about it.